Good. So can anyone tell me how that relates to, say, a for loop? No? Okay. So, erasers. Okay, so if statement do if x is, I don't know, 5, whatever, and then you do stuff. So this for loop, there's 3 parts to it. And so this is the part that relates to this part. So in the beginning of the for loop, I suppose, does anyone know what the 3 parts of the for loop are? Did I know about over with people? Someone else in Sushi. No? I swear to God, all of these things. Yeah, actually.
Wait, so what is a for loop?
What is a for loop?
Yeah.
Okay, that's right. That's a good starting point. It's a loop. So this if statement is only going to run exactly once, and so you could have a series of if statements that they each check it every time you go. Like in Arduino, it's constantly looping. And yes, but it's only run once per loop. This for statement, this for loop will run a certain amount of times depending on what happens in the program. But yeah, so this is a loop versus this is not actually a loop, it's just one statement. And you could make it complicated, you can add else's or a marker. So you can add some else's. So if x doesn't equal 5, then you can do something else. Or you can make it more complicated and add an additional. If x equals 3, then you do things. And then else, if it's not out of those things, then you do something else. So this for loop is it's going to run the same amount of times. And so there's 3 parts. There's beginning, check every time, and after each loop. So if we say that x is 0, so I'm saying I'm setting x to 0 because that's what single equal. And feel free to move forward. That's so stupid. And I do x is less than 5 and x plus plus. So the 3 parts is before the loop starts, I'm going to set x equal to 0. Then I'm going to check to see if x is less than 5. At which point I will then run whatever's in the for loop. And then after that's done, I will then add 1 to x and just make that check again, and then run the loop again until this check is false. So, as I said with the if this is false, then you don't run the loop. If it's true, then you do run the loop. And so it's a fancy if statement, because as far as the computer goes, if statements and for loops aren't all that different. They're just have a few extra components. So can anyone tell me how many times this loop was run?
4 times.
4?
Or actually 5 times.
Okay, and why 5?
For 0, 1, 2, 3, and 4.
Yeah, exactly. Okay. And yes. Does anyone actually follow that? I'm not sure. Does anyone know why it's 5 times? If you don't, I want to try to explain it a different way. But no, that makes sense? Okay. Okay. So what else am I saying? Do that. So for loops. So that's one type of loop. You can do it in a different way. Instead of having this set up x equals 0 and do these 3 parts of it, you can just say, well, x is less than 5. And you just start this loop. That's you just check is x less than 5, then you go and do everything in this loop. But as far as the compiler is concerned, these things can be exactly the same. It's just oftentimes when you write a while loop, you molecule runner problems where you have a loop that goes on forever. Whereas the for loop generally you can see where it's starting, you can see where it's ending, and see how it's going to change, and then you can get to the end eventually. Whereas while oftentimes you just end up stuck forever and the program never stops. And do while is the same sort of thing as while, except that instead of the first time we check it, instead of check it the first time, we would say, do something while x is less than 5. So it would always do it once, but then it would check to see if it should do it again and loop over and over and over and over again. And the things I always need with computer programming is the fact that you don't actually need either of these things. You can get away with just using if statements. It's just, if you're trying to run something 5 times, it's a whole lot easier to do a loop and not repeat the code than it is to just make these statements repeatedly. And then, who's heard of the switch in code? Okay. So switch looks, so switch is on some variable. So just make it the x, whatever. And it gives you cases. And so, yeah, that's how it looks. What a switch really is a series of if statements. And so instead of writing it out as if x equals 5, else if x equals 3, you can just have case 5 and do a switch on x. And basically just get a cleaner way of presenting it. But again, the thing with programming is you can do it any way you want to. It's just whatever makes sense to you conceptually, or whatever someone else will follow along with. Like for me, the series of these statements is harder to read than it is just have a switch where you know I'm going to have a bunch of different things that I'm going to ask you about x, and whichever is true, I'm going to make them execute. Okay, and so next thing, return, break, continue, and so okay, let's see, around the column for a second. Agnes, can you tell me what any of those things do?
I know you put break, or I put break in like after the cases in the switch loop.
Mm-hmm.
So that's
Do that break there? Do you know why you do that?
No.
No? So break you can use in a switch statement, you can use it in the for loop. And so in this case, this for loop, you can have, you could say if x equals 3, break, then it would mean that if x happens to equal 3, you wouldn't actually go through this loop 5 times anymore. It would get to 3 and then break out of the loop and continue on going. And so sometimes this is useful because it's like, sometimes you know that your servo motor is turned far enough and you're not going to turn it anymore, so you know that it's just time to break out of this loop to try to make it turn more and go on to some other part of the program. And so when you get to some maximum limit, you break out of the loop because you want it to stop right then. And in this case, is the switch statement it's fancy, and if you didn't include this break statement, it would case 5 would also run case 2 and all the way down, and so you can do dangerous things. Whereas the break stops that from happening, so you only do whatever's in case 5. Okay, so that was break. Anyone know when you use return? Okay, Hannah?
So when you return, like after you do the loop, it goes back to the top, and it like redoes the whatever command you're doing.
Not how I mean it. I mean it's in the when you actually type the word return. And sometimes people use it with functions. You've probably seen it in functions. Your answer is good, but not the way I was thinking of.
Usually it would give you a value.
Yeah, exactly. So we might be in all of this messiness might be in the middle of some functions somewhere, and we decide we want to return a value. This is contrived. But yeah, so instead of if x equals 3, instead of breaking and just going on in the program, we return x. And so then this would not just break out of the for loop. It would if this was part of a larger function, it would go all the way back out of the function entirely and give them 3 as the answer. Yes. Let's see. And so goto is something you basically shouldn't use, because basically goto goes anywhere. And so most languages don't even let you do it these days. But in like some older languages or something like assembly or some other lower level languages, it's just, you can go to any random spot in the code, and that's just the way you program it. And continue is, if x equals 3, instead of breaking out a loop, you can just continue. And that would make it so just continue on to the next iteration of the loop. Okay. Good questions? Am I boring you? Probably. Okay. So intro to data structures. Who's heard the term data structures before? 1, 2, 3, 4, 5, 6, okay. Not bad. Who's heard of a tree in programming? About the same? Okay, so similar sorts of things. Who's heard of, I guess, trees, yes. Who's used an array? Okay, a few. So, what's fun about data? About data structures is it's a way to think about how your program is structured. And some of this is going to be way too complicated for what you guys are doing now, but it's kind of a nice thing to know for just like how computers work in general. So, let's say that we have, in the computer, we have things that are right next to each other, and we have things that are separate. Which do you think is going to run faster? Or is it going to be easier to find, faster to find the memory stuff?
The stuff that's together.
Yeah. And so this would be an array. With an array, you can keep track of your numbers. And if you know you're here and you want to go to the next number, you can just add, and the computer will know, okay, the next number in the array is just going to be the next number. If you're doing something like this, you wouldn't know that this is next because there's going to be some anywhere else in the computer entirely. And so you have to have a little something that points to it. And so you have to actually link them together. But this becomes super useful when you don't have any idea how much stuff you're going to make. You can just, okay, I don't have enough memory here, but I can just, okay, I can go over here and put some more data, and I can just put them together. And so you can just make your structure grow bigger and bigger and bigger, and just use up what space you have, as opposed to this, where it requires you to have lots of space all together all at once. Kind of like, I don't know, the space to put these 4 tables versus the space to put 4 tables together. Yeah. And so this is a linked list. And the other random data structure is a tree that I'm mentioning. And these, so this is a binary tree, so this is the root of the tree, and it kind of grows like you'd expect a tree to grow. And what's neat about it is think about like a tree when you're in real life. So you have one root, and by the time you get to the top of the tree, you have like 400 branches. And it doesn't require the tree to be thousands of feet tall to get to 400 branches. You can get there within only a few months, like 20 or 60 feet or whatever. And so, yes. Anyone have any guesses for when this would be useful as a general concept? I think that's going to be a hard question. If you want to shot. Think about an alphabet. So with this tree, we can make it so that M is here, and anything to the left of the tree is going to be something that's less than M, and anything to the right of the tree is going to be something that's greater than M. And so, it's, D, A, L, and Q, S. So now, if we're like looking for names, so we have very two people with names in a single letter, and we want to try to find a name. We don't have to go through all of these items. We just have to know, okay, is the name before, like if we're, say, Agnes, making a new guess. So I know M. Okay, is your name before or after M? So we'll go to D. Is your name before or after D? Okay, and so A, and there we go. We found Agnes, and it took us 3 steps. If we done it in this array instead with this list of characters, if we did started over here, obviously with A, it would have taken us 7 steps to get there. And so the data structures just help you organize data so it works faster. Okay. I want to try a simple coding problem. We'll see how this goes. Okay, so the problem is going to be print numbers from 1 to 10. Okay. How would I start? Okay, so we have our program, and it does stuff, and there we go. We have a program. This is called. It started the program. What am I going to do now? Any minute, how would you print a number? Like an Arduino? Yeah. So we'll do something like that. Well, print. So what would I do with that if to try to make a number? Just
do 1, 2, 3, 4.
Yeah. Okay. So that's good. So I'm just quoting. Okay, so that would work. You definitely just solved the problem, and that was an excellent way of doing it. Obviously requires 10 lines of code in order to do that. So that's a good answer, and it's a good brute force answer. And when doing these problems, that's the best way to do it first. Is to figure out how do I just do this? What do I know? So does anyone remember a way to make it? Okay. Yeah. What? For loop. Yeah. Okay. So what would I change about this to make the for loop?
Well, in front of before the print, put 4.
Okay. And like, what would I be putting inside the code?
I equals 0. I is less than equal to, or I equals 1.
I equals, double equals 1?
I equals 1 is right. It doesn't matter due to my number. But I can only I is less than 10.
Oh, I is less than 10? Okay. Or no, so you're out. No, there's not. So I equals 1, I is less than 10? Less than 10. Okay. Jennifer, can you explain that? Can you explain it? Do you remember the for loops at all? You don't know.
You just run it through the loop and then it increases by 1 until 10.
Yeah. And so what else do I have to change? Julie?
Print I.
Julie? Yeah. Oh, sure. Yeah. Sure.
I just said you print I.
Yeah. Absolutely. So yeah, so now you've just done the same thing that took 10 lines before, and you've just done it in 2 lines. And the fun thing is when applying for jobs these days, most of the time they'll have you answer things like that, but so if you ever want to try out actual difficult coding problems, read code, like combating and suggesting. Okay. Okay, Arduino basics. Okay. So, set a loop. Okay. So, let's see. And okay. Look, tell me how many times setup runs.
Just once.
Just once? Okay, how many times does loop run?
Forever.
Good. I don't know where to go with that. Anyone know what the include serial.h or something.h does? Picture?
You say to include a library?
Yes.
Like a function from a library. For
Yeah.
this.
So, next question with that. Is there a setup and loop in the serial.h? Yeah?
What was the question again?
Is there a setup and loop function in that library file, alpha file?
I don't think so.
Yeah, and there isn't, because it would, if it were, it would just wouldn't compile at all. So this serial.h file is, I mean, you guys are posting with libraries. Has actually worked with Arduino? I know some people just aren't. So there are things like some, I don't know, such like Raspberry Pi or other wacky things. Yeah. So this .h file. So it's called the library, and this has all of the functions in it, as Victor said, that you might use in here. So it is serial, and then maybe that's where you get the serial.print from. And because it's there, then you can do this. If you didn't include this, then you couldn't say that. I know that's not actually accurate, but you get the idea. So anyone know what the .cpp file does, or have any idea? Here's, yeah. Kind of ask the question. So normally when we include these libraries, if you so how many people have downloaded a library that they included into their project? Okay, so a few more. So what files did you have to download? I guess you.
Oh, I downloaded a module for Python.
Okay, so that was okay. This can be similar, but not quite that exact thing. You did it, but you don't remember it?
Yeah, the budget code file, like apply the codes.
Yeah. This is what?
The budget codes, like defining those apply.
Oh, you did define. So, like, what was the library file then? Oh no, you just copied and pasted
Yeah.
the. Okay. Yeah. This is also neat, but not quite what I was thinking of. So yes. Anyone else? You did. Okay. What did you download?
The text, the CPC, and the .h.
So the text file shouldn't have done anything because it doesn't actually have any coding stuff in it. .h has like the .print or whatever functions it has, but it only has the definition. It doesn't actually have the code to make things go. This is why you couldn't just have the .h file, you had to have the .h and .cpp, because this one has the actual instructions. It doesn't just have the general, these are the functions that are available to you. Yeah. Anyone else have any burning questions? I think I probably should have done a different structure for this, but not quite sure how. Yeah. Does anyone have like an interesting coding project they've done previously? I was sort of wondering what's okay, I don't know what to go to next, so I guess I'm going to call it there. Yes, anyone, please tell us if you have other ideas for talks. I'll probably do a GitHub thing. Who's used GitHub so far? Okay. And the rest of you probably should use GitHub. Because it's a way for saving your code so that when you accidentally write something, you can go back to it and it makes sense. And so you can share your code with other people and they can all look at it. Compare and contrast. So yeah, I guess thank you for your attention.